Tom Richardson from Powerside. What we'd like to do this time is we'd like to look at the consequences of a capacitive load. So let's go through the basic steps again. Validate the voltage on the source side, validate the voltage on the load side, and here again we have single-digit currents. But this time what we expect is a more capacitive load, so we're expecting an inrush which may be significantly higher than we would have for a resistive load. And already we've preempted that by changing the circuit breaker setting here to 100 amps. So let's look at what the characteristics of this operation were. The unit is ready. Again, recommendation, just a 10% sag, right? So 90%, 2 cycles only. And let's go make sure that the selector is in the right position. And let's go and fire and see what happens this time. So we arm and fire. And already, let's look. The unit is returned, it's recorded, but let's look at what we see also on the front panel here. We can see that there's been a 10 amp draw maximum, but remember this is a relatively slow speed or a relatively slow recording, RMS recording. What you really need to look at is the graph and the characteristics of the graph to understand what the consequences of this sag were. So with that, I already have some. We can begin the download up here. We can download the file, but already I've pulled up on the screen here that going from a nominal current on the load side, we can see these significant spikes that occur even with a 90% sag for only 2 cycles. We can see that the peak current here is somewhere between 60 and 100 amps. Now that's significant. Why is it significant? Because if you understand what that inrush is and you understand what the peak amperage is, then first of all, there are limits to the IPC, a 200 amp limit that you need to be sensitive to. And also, you need to understand the impact on the tool. So it's very necessary to start with the process of a gentle sag and look and see what happens in terms of inrush. So with that, we're ready. I can go into further examples, but hopefully this gives you a better understanding of the different characteristics of a resistive equipment under test, EUT, and a capacitive one. Thank you for joining.